Now let's see machine dependent optimizations. These optimizations are done depending on the machines, right? So it is not possible that we can do this optimization on all the machines, because depending on the architecture, the platform, we have some facilities already provided by that platform. So depending on that, we are going to do this. Okay. So first one is register allocation, local allocation and global allocation. So register allocation, that depends on how many registers you have, and depending accordingly the number of registers we can do the allocation. So it is purely dependent on the architecture. If you have 4 registers, then lot of moving in and moving out has to be done, because we cannot save a variable in 4 registers. I mean, we can only save only 4 variables in the 4 registers. Therefore this one is purely dependent on the machine. Anyways, we are going to see this register allocation in CO topic, and we need the graph coloring algorithm also. Okay, and next one is use of addressing modes. So addressing modes also I'll discuss in CO. And next one is peephole optimization, redundant load and store elimination, which means sometimes what we do is we load something and immediately we store it back, right? That is simply a redundant thing. Then what we do is in such cases what we do is, so I'll just take an example and explain you. Let us say this expression x equal to y plus z, this statement is generating 3 codes, three statements. First thing is move y into r naught and then add z to r naught, which means it is nothing but y plus z is added, and then move r naught to z, which is nothing but y plus z is now moved to x. R naught to x means y plus z is now moved to x, right? And if you look at these 3 statements, and if I have these 2 statements, a equal to b plus c, d equal to a plus c. Now for each statement, if I am writing 3 statements like this independently, individually, then what is this mean? I am moving b into r naught, and then I am adding c to r naught, and finally the result b plus c is in r naught, and I am moving the result b plus c into a, right? And similarly I am doing the same thing for this one. I am moving a to r naught, and then I am adding e to r naught. Now the result r naught contains a plus e. Now I am going to move that r naught into d, which means a plus e is assigned to d. Now if they are independently executed, you don't see anything, but when I combine them, then there is some redundancy here. This is a load store problem, isn't it? What we are doing is we are trying to store it back, which means the value into a, and again we are trying to load it. So loading and storing is there, so this one has to be eliminated, right? This is optimization. Now look at this flow of control optimization, which means sometimes the control flow will be in such a way that it is redundant. For example, jumps on jumps. See this? Now L1 is saying that jump to L2. Now if we jump to L2, L2 is saying that jump to L3. Now if you go to L3, it is saying that jump to L4. So unnecessarily you are jumping these many times. Actually this should have been written as simply jump to L4. That would have been sufficient, which means directly going to L4 is what you needed, but you are going these many times. And next one is eliminate dead code. So hash define x as 0. So if I define x as 0, and if dead code is eliminated this way, see this, already if x is 0, now if x, then some code is there, this entire code is called dead code, because this 0 is never going to become 1, because it is already a constant. The x is a constant, nowhere we are going to change the program. Therefore instead of compiling this code, you could have easily left it out. So compiler need not compile it and generate the code unnecessarily, because that will never get executed, right? And now use of machine idioms. Machine idioms means, now let us assume that we want to increment the value of I by 1. Then what we generally do is we load the value of I into r naught, and then add 1 to r naught, and then again store that value back into I. So these 3 instructions are generally carried out in most of the processors. But if your processor is rich in the sense, if you have a rich instruction set, if you have special instructions like increment I, then you need not go with these 3 instructions. Instead of that, you could have gone with only 1 instruction. So these are all the optimizations which you could do on machine. I mean, these are all depending on the machine. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, There are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.